Okay, so in this lesson we're going to work with the Pythagorean theorem. Okay, I'm not going to introduce what it is. We're just going to browse through the problems. We already know that Pythagoras theorem says that the hypotenuse, okay, the square of the hypotenuse is equal to the sum of the square of the two sides. So c squared equals to a squared plus b squared. The converse is also true. Converse means when you switch the statement around. So I could say that a squared plus b squared is equal to c squared. All right, a couple of facts that we need to keep in mind are the following. We have something called Pythagorean triplets. What does that mean? It means that there are certain numbers that you should know in order to recognize that it is a right triangle. For example, a 3, 4, 5 triangle is a Pythagorean triplet. How? Well, look at this. In any of these three numbers, you should be able to recognize which one is the hypotenuse. The hypotenuse is the longest side. So therefore, 5 would be the hypotenuse here, 13 would be the hypotenuse here, and 17 would be the hypotenuse here. So, let's see if it's true. So 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Well, 5 squared is 25. So basically, this 25, okay, 9 plus 16 equals 25. 9 plus 16 is 25. Therefore, it checks. So this is a right triangle. Now, can I create my own Pythagorean triplet? Yes. If I multiply everything by 2, I get 6, 8, 10. This is also a Pythagorean triplet. Look, 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. And 10 squared is also 100. So it checks. So that's a way of creating. You can multiply this by 4 if you want to. If you multiply this by 4, what do I get? I get 12, I get 16, and I get 20. This is another Pythagorean triplet, so you could create your own. So these are just examples of Pythagorean triplets, okay? If you want to check, you could check. Let's move on. So Pythagoras theorem. If we have a right triangle with side lengths 6, 8, and we need to find the hypotenuse, well, we do 6 squared plus 8 squared equals to x squared. So basically that's what we have. Or the converse, x squared equals to, okay, 6 squared is 6 squared is 36. 8 squared is 64. So therefore, that's 100. So at the end of every Pythagorean triplet, I'm sorry, oh my God, what am I saying? At the end of every Pythagorean theorem, okay, we are going to take the square root of x squared, or whatever square that we have. It could be b squared, it could be m squared. The thing is that this is the hypotenuse, and we are going to take the square root. Why? Because we are not interested in the area, which is the square. We are interested in the linear term, okay? Just x, not x squared, just x. So to undo the squaring of a number, we take the square root of that number. Look, to undo this, so square root of 100 is 10, because 10 times 10, or 10 squared, is 100. Okay, let's move on. So the answer is 10. It says, which set of number does not represent the size of a right triangle? Justify your response. Sure. So let's see, I need to find the one that is not a right triangle. So how do I do this? Well, first of all, I gotta figure out what the parts of the triangle are. So these are the two sides, and this is the hypotenuse because it's the longest side. Hypotenuse, hypotenuse, hypotenuse. Okay? So now let's see which one it is not. So 6 squared is 36, plus 8 squared is 64. 36 plus 64 is 100. 10 squared is 100. So the sum of these two is 100, and this is 100. It is a right triangle. Okay then. So what you do is the same for all of them. So for example, I'm going to take this right here. So 8 squared plus 24 squared, okay, is 640. So now 25 squared is 625. Therefore, this is not a right triangle, because you see the two quantities are different. The sum of the legs square, okay, sorry, the sum of the squares of the legs is not equal to the hypotenuse square. Okay, here. So we have a right triangle. BDA is 90. BDA is 90. This is 90 right here. Now, the length of AD, okay, is 5 radical 2. This is going to be a very long lesson. The length of AB is 2 radical 15. Okay, they want me to find the length of BD. I could call it X or I could call it BD. I really don't care. So, just in case, okay, you could use BD or X. I'm going to use BD just for the sake of doing it. So, this is a leg, this is another leg, and this is basically the hypotenuse. So, what do I know? C squared is equal to A squared plus B squared. See, BD. I call it BD. Or you can call it X. I really don't care. Alright then. So something peculiar happens when you have the square root of a number and then you square that number. Squaring and taking the square root are inverse operations. What does that mean? That they cancel each other out. Just the number that is inside the square root. Okay, so let's see now. 2 to the second power is 4 times, because this is 2 multiplied by radical 15. So square root of 15 square cancels out the square root, so just leaves the 15. 5 squared is 25 times the square root of 2 to the second power cancels out the square root, so therefore they cancel out, so therefore this is just the 2 plus BD, the square root of BD, right? Okay, so this is 60, this is 50, and this is BD squared. Okay, subtract 50 from both sides, that leaves you with 10, and then this disappears, and that's BD to the second power. I don't want BD to the second power, I want BD, so I'm going to take the square root of this number, okay? So I'm going to say the square root of BD squared, and what you do to one side, you do to the other. So BD is equal to radical 10. Now, why do I leave it in radical 10? I could say that this is 3 point something, but since the multiple choice, okay, states that the answers are in radical form, then I found my answer. All right, let's move on to the next page. Okay, so here we have a diagram, and we are supposed to find, this is an isosceles triangle, and we're supposed to find the length of the base. Okay, so how do I do this? Well, first, let's have some practice doing binomials, okay, just in case. So if I have x minus 3 squared, right? What is this? This is the same thing as x minus 3 times x minus 3. Okay, if you use the distributive property, you already know that this is going to be x squared, then this is negative 3x, that this is negative 3x because I'm multiplying, and that this is positive 9. Okay, now at the end you get x squared minus 6x plus 9 because you add the negative 3x's. The question from me to you is the following: how many times do you see 3x in here? Okay, twice, right? Not only that, negative 3x. How can I get negative 3x without doing this? Easy. If I put this negative 3 and times it by this, I get negative 3x. And if I double that, I get negative 6x. Oh, okay. So let's see if the same holds true for the next one. X plus 3 squared. Okay, so what do I know? That this is x plus 3 times x plus 3, like this, right? And then I'm going to multiply x squared. X to get x squared. So my shortcut to you will be the following, and this only works when you are squaring a binomial. This is a binomial square. So square the first term. Now multiply the inside and double it. So 3 times x is 3x, double that is positive 6x. And then square the second term. See that? Let's do another one. Let's have x plus 7 squared. Okay, binomial square. So what did I say? Square the first term. Now multiply the insides and double it. So 7 times x is 7x. Double that, 14x. And then square the second term, plus 49. Let's do another one. X minus 8 squared. So let's see. Square the first term. Multiply the insides and double it. Negative 8 times x is negative 8x. Double that, negative 16x. Then square the second term. Negative 8 squared is positive 64. So what do you notice? Well, that this symbol belongs to the first sign right here. Look. Positive, positive. Okay, negative, negative. That's how it goes. All right, and that's basically how you multiply it. That's just to make it easier for you instead of using the distributive property that we use right here. But it only works when we when we square a binomial. All right, so now we're ready to start doing this. So let's see now. The length of the base. Well, this is an isosceles triangle, and this is an altitude. Okay? So basically, what am I saying? That this chops the isosceles triangle, the base, in half. So this whole thing is 2x, but chopped in half gives each of these halves just 1x, because 1x plus 1x is 2x. All right. Now, what do I have here? We're dealing with Pythagoras Theorem, so we have a right triangle, so we're going to have to use the Pythagorean Theorem. C squared equals to a squared plus b squared, or a squared plus b squared equals c squared, however you want to look at it. So let's see now. C squared, 13 squared, okay, is equal to, okay, which triangle you want to work with? Okay, I'm going to work with this one. It doesn't matter, whichever. Okay, now equals to a squared, x plus 7 square plus b square, so plus x square. Okay, dealing with this. Oh, so 13 squared is 169. Now what is x plus 7 square? Remember, binomial square. So this is square the first term plus, because this is a plus, multiply the insides and double it. So 7x double 14x plus x squared. All right, so this is a quadratic equation now. Let's add the like terms. So 169, okay, 169 is equal to x squared plus x squared. How many x squares do you have? 2x squares, right? Plus 14x. Okay, cool. Quadratic equation. What do I know about quadratic equations? All quadratic equations must be equal to 0. This is not equal to 0. This is equal to 169. So what am I going to do? Easy. Wait, I made a mistake here, and hopefully you caught it. I did this, I multiplied the insides and double it, but I forgot to square the second term. That's plus 49. Okay, so then here I get 2x squared, oh yeah, plus 14x plus 49. Okay, now we're talking. This is x. All right, so I'm going to set it equal to 0. So I'm going to subtract 169 from both sides. So that automatically makes it 0. And now, remember, 169 was subtracted. So what is 49 minus 169? That's negative 120. Oh, and anyway, even if you didn't know it, you're going to learn as you go. Okay, let me move down here. So, this is what I have. So I think I can factor this. If not, I'm gonna have to use the quadratic formula, or I'm gonna have to complete the square, which I have not taught you yet. That's on the next lesson. So let's see. To factor, first I extract the GCF. What is the GCF? The GCF is the greatest common factor, the number by which all these numbers can be divided by. So I do. If I divide the whole thing by 2, okay, so in other words, everything here can be divided by 2. So extract the 2. And now to factor, once you have extracted the greatest common factor, then we proceed to factor. So I forgot that I need to write what was left over. So let me do it. Okay, what happened here? Okay, So if I divide by 2 here, I end up with x squared. If I divide by 2 here, I end up with 7x. If I divide by 2 here, I end up with 60. Okay, now we're talking. Now I can factor. So once again, I write it down. Open the parentheses. Now let's see. Factors of x squared, x and x, because x times x is x squared. Factors of 60, 12 and 5. Now to check for the middle term, okay, do a smiley face like this. Okay, if I can get the middle term from these two factors, then I'm good. If not, I'm gonna have to figure out what other two numbers multiply give you 60. So let's see now. This is 5x and this is 12x. Can I get 7x? Yes. Make the 12 positive and make the 5 negative, and I found it. Okay, is this the last step? No. I still need to figure out what the value of x is. So how do I do that? Easy. You set each of the factors equal to 0, because at the beginning, that's what we said, that it has to be equal to 0. Okay, so let's see now. How do I solve for x here? Subtract 12. So x equals to negative 12. How do I make this 0? Easy. Add 5 to both sides, so x equals to 5. All right, now for the purposes being, we're talking about the measure of the base. I never heard anybody saying, oh, look, this thing is negative 12 inches. No, I heard him say, oh, it's 5 inches, because it's positive. So we use the positive number to measure distance. So x is 5. Question is, what is the length of the base? Well, I'm gonna let you figure out what the length of the base is. So make sure you write the length of the base is boom. Okay, let's do the next problem. Okay, so basically they want to know what is the measure of the vertical support being right here. Well, as you can see, I have a right triangle right here and a right triangle right here. So I am going to use Pythagoras Theorem to figure out, because I know that they're not asking me for an angle, they're asking me for the sides. And I know that usually right triangles, sides, has to do with Pythagoras Theorem. Okay, so we got 7 inches, we got x inches, and since the hypotenuse is opposite to the right angle, so it points at the hypotenuse, so I know which one is the hypotenuse, x plus 1. So that's exactly what I'm going to write. So I'm going to write the hypotenuse, x plus 1 square, okay, is equal to 7 squared plus x squared. All right, so now what do I know? Well, that I need to expand this. So x plus 1 squared is nothing more than, and you already practiced this, so x squared plus 2x plus 1. Square this one, multiply the insides and double it, and then square the second term. 7 squared is 49, and of course plus x squared, because I'm not done yet. Okay then, so it looks quadratic in nature because it has the x squares. But watch what happens. I mean a plain side, because I know, okay, I did this problem before. If I subtract x squared from both sides, what do I get? Minus x squared, they cancel out. So they leave you with 2x plus 1 equals 49. Yes, not everything that shines is gold. So basically, we lost the quadratic equation. But that's good. That means that we only have to solve for x. So what do I do that? Well, subtract 1 from both sides, and you get 2x equals 48. Divide by 2, and you get x equals to 24. X equals 24. You have to read the question. The question is, what is the measure of the vertical bar? So make sure you write down the measure of the vertical bar is, okay? Good. Problem 1. Okay. Oh, the quiz. We did this. Yeah, I've done this before, so I'm not gonna do it. All right, so I'll see you on the next lesson.